Hello, everybody. Can you hear me?
Yes.
Yes.
What's going on? If you could stop it. Thank you. So, hello, welcome to our Global Construction Tech Program Innovation Session live from Paris. Today's event will be dedicated to the topics of energy and clean tech in the construction sector. For today's agenda, we're glad to welcome Yuri Akiyama from Shimizu Corporation, one of Japan's leading companies in the construction and civil engineering sectors. And Talia Rafali as well from Compass, an early stage venture capital firm focused on solutions that accelerate the digital transformation and decarbonization of the building and manufacturing industries. I also see a couple of familiar faces. So, hi, good morning. So, before introducing our speakers for today, I'd like to say a few words about our contact program. Um, we at Impulse Partners have been passionately dedicated to the construction innovation sector for over a decade now. Our main goal is to speed up innovation in construction, real estate, energy, infrastructure, and bring together the key players of these sectors in a global scale. To do so, we've developed a global ecosystem of entrepreneurs, tech firms, VCs, and decision makers that play a vital role in accelerating innovation, driving economic growth, and solving complex societal challenges. By bringing together those key players, fostering collaboration, providing resources, providing support, and creating an enabling environment, these ecosystems unleash the collective potential to develop and scale innovative solutions that have a much bigger impact, a positive impact on industries, economies, and society as a whole. So for us today, the Global Construction Tech Program is the materialization of all the efforts we've been making to bring together these players in the value chain within this network. So if you've been invited to today's session, it's because we firmly believe that your company can play an important role in the technological transition to a greener future and have a strong impact in the construction sector. So thank you for being here. While joining our global initiative, you'll have access to world-class startups through our network of over 3,000 companies and startups, access to equity benefits, access to venture capitals, investors as well, CVCs, VCs, as well as pilot programs to test and validate startup solutions. And as we're doing here today, you'll also have the opportunity to meet industry peers, share best practices, and develop your innovation network. So this was just an overview of our activity. But if you're interested in having more information about the program, please do not hesitate to get in contact with us in the email that is in your screen right now. About our speakers, coming up today, we'll hear first from Yuri Akiyama, Senior Associate at Shimizu Corporation, and then from Talia Rafali, General Partner at Compass, that will present the company and its activities. We will also hear the presentation from 5 startups who will be showcasing their energy and clean tech solutions. And by the end of each presentation, we'll have a few minutes for Q&A and open discussion. Please use the chat or activate your microphone for this. I do invite you, though, to mute your microphone during the presentations and only activate it at the end. Well, to begin, I'm very glad to welcome Yuri. Hi, Yuri. Are you there?
Yes. Hi, good morning. Thank you so much for inviting us. We are really honored to be here. Thank you. So, can I start now? Yeah.
Yeah, absolutely.
Okay. Okay. So, we are Shimizu Corporation. I'm from London office, Yuri. And so this is a little bit more about Shimizu Corporation. We are this is the founder his case, Shimizu look like a samurai, right? Because we are founded in 1804, 220 years ago. And about annual sales is about 11 thousand million pound annually. And so, yeah, please go ahead. Okay, so then our business model is quite unique. We involve in not only in construction management, but also from planning, design, and construction management of architecture, building, and infrastructure as well. And also, we currently we have about 10% of a portion on the non-construction business, which is real estate development and engineering, like energy sector, and life cycle valuation and frontier business, more like for sustainable actions. And we have a great global network with 32 global offices in the world. So yeah, definitely. I'd like to introduce our new accelerator program afterwards, but you guys can use our great network. Yeah, and this is our sustainability in a smart innovation vision by 2030. We would like to focus on the resilience, inclusive, sustainable society to realize that. Yes, so this is, yeah, now I'd like to introduce our new accelerator program called Shimizu Next. This is we aimed at solving a solution issue by realizing a resilient, inclusive, and sustainable society. And we have currently we focus on three main pillars, which is construction and urban design, and resilience, and environment and energy. Next page, please. Yeah. And first of all, from first pillar, construction and urban design, we would like to focus these 3 points. Like first one is a new way of construction, such as DX and modular construction. And second one is adapting to diverse way to working and living, uh, such as a digital transformation of a real estate, digital twins, new way of working. And finally, the third one is a smart city. And this could be people flow analysis, mobility, community collaboration. Yeah, next page, please. And then from second pillar, from resilience, this is, we would like to focus on like disaster prevention, mitigation, and prediction, and also security and the BCP measures. And finally, from the third pillar, and environment and energy. Um, so from energy, energy saving, renewable energy, and storage, of course, and most important thing is decarbonization. This is we would like to focus on CCUS, CO2 emission, how to calculate those carbons, and also low carbon materials. And finally, circular economy. Yes, sorry, it's all right. Yeah, go ahead. And so, yeah, so here, this new acceleration program, we just opened last year, winter time, and we just launched the application, the call for application in November last year, and we have received 79 applications across the world, including 36 from abroad. And eventually, in this year, in February, we finalized to choose 60 partner company from this acceleration program. And as you see, some of them are from Europe and of course from Japan as well. But mainly as we focus on our those tamers, three pillars. We chose like a off-site construction, modular construction, uh, smart water monitoring, metal printing, and next page, please. And some, about DX and CO2 capture technology and so on. So this is Our accelerator program is quite flexible. First of all, we have our own POC budget, and we can start some POC at anywhere in the world using our uh, global network. And also, we currently only inside of Japan, we have 800 ongoing construction site, and this global network, and definitely you can use those our asset for your POC and our collaboration. And after program, we can continue ongoing POC, business alliance. We have our own CBC investment, joint venture, and also we could have opportunity of M&A in the future if everything going well. Our CBC budget is about 10 billion yen, which is about 76 million pounds annually. And yeah, so next page, please. So uh, next acceleration program will be open maybe around the spring or summertime next year. However, we would like to discuss, we would like to start a discussion as soon as possible. And so we can, please feel contact us anytime through the year. Thank you very much.
Thank you, Yuri. A
Thank you.
question, do you already know the verticals, the topics you're going to be looking for
Uh,
next?
So we haven't opened yet, but I think mainly it's gonna be same than last year. And also you don't need to stick on those. We would like to focus on those topics.
Mhm.
However, if you believe this is a great collaboration in different topic, and please feel contact us, and it's we are very flexible about it. Yeah.
Okay, thank you. Does anyone have a question? Thanks a lot, Yuri.
All right. Thank you.
I'm now glad to welcome Talia, who will present us Compass. Are you ready, Talia? I think we lost her. Well, in that case, Talia, she's having some problems with connection. Uh, no problem. In that case, I would invite Magister to start pitching if you're ready. Ceylon?
Yes, we're ready.
Yeah?
I'm
Okay.
going to share my screen in that case.
So the first pitch will be Magister, an online register for materials, allowing users across the construction value chain to gain insight into specific materials properties to help reduce waste and CO2 emissions.
Okay, so I think you can all see my screen now.
Yes.
Yes, thanks. So I will quickly introduce myself. My name is Ceylan Yazıcı. I've been working for Madaster now for I think 1 year. Besides that, I work also at an architecture firm, and that are two things I will combine. Today, I'm going to tell you a little bit about Madaster. We are with a big group of individuals, which each have their own expertise. But I think one thing we all have in common, one major thing, and that's that we all, if my presentation, we all live on this beautiful thing, our home. And it needs help with the climate crisis we have now. And we always start with this slide because we think the Earth is a closed system where there's no needs to be waste. So the purpose is that certain raw non-renewable materials are limited, and in order to reuse them as good as possible. There are some technical problems here. I'm sorry. Yeah. So yeah, we can't grow steel, for example. So the materials we have are all like a limit edition, and by registering it, we believe that reuse will be a lot easier. So the urgency of the circular economy is yeah, it's quite big. So we see the sustainable development goals. These are like quite big goals, and now you see more and more that they are becoming more practical ruling and all that kind of stuff. So if you see ESG and EU taxonomy, these are examples that big companies within the EU yeah, really needs to report on their emissions and impact on the environment. Yeah, both are important on circular design, and like in countries, for example, here in the Netherlands, we have also platforms and BREEAM, which you can use also to gain more like in the sustainable information. So the urgency we see also here and in the over the world is the global budget for CO2 for the 1.5 degrees ruling is that we have 400 gigatons worldwide. Within the Netherlands, it's 909 megatons, and only like the construction site within the Netherlands, we have 100 megatons, and this is calculated by the total of inhabitants within the Netherlands. So if we don't do anything within the sector, we would exceed our carbon budget within yeah, a couple of years. So in 2027, we would exceed that. And this is not specific for the Netherlands, or so this is specific for the Netherlands, but I think every country will have this, and we all need to yeah, have a lot of work in order to not override the CO2 budget. And that's where we coming, as we as Madaster will provide a tool to gain insights in a couple of APIs. So we started as a register, and we are becoming more and more now a tool in order to gain more insights and circularity data, and implement that within your business to reach that goals you have. So Madaster generates insights into materials and products and use their locations as well as their impacts on the environment and their future financial value and potential reuse. And we think that if you are registering it, it's becoming more clear how you can reuse it, and we can drastically reduce CO2 emissions and waste. So how does that work in practice? So here you can see like a little visual how Madaster works. So firstly, we have an input that we can see as an Excel template or a BIM. And the second one, the BIM model, we use an IFC format, and that's the one we use the most. So the more input we have, the more output we can generate within the platform. So you will load in a BIM or an Excel, and this will have some circularity data. Within the data, it will be connected to a database, which can say, okay, we will connect circularity data of concrete within the BIM model, and we can do that broadly within the whole model. And what that will do, if the whole model is linked to the database, to the circularity data, we can gain insights. We can generate the material passports. We can say something about circularity, embodied carbon, and financial valuation. And this is all an automated process in general. So it's all automatically linked, and you can all automatically get those insights out of your BIM model. And it is possible to link external apps. So for example, urban mining, that you, if you know what's inside your building, you also know what's coming out of that within 50 years. And you can also always like get those materials on a product marketplace, but these are like future developments. So what's in it for you within Madaster? It is quite a text-intensive slide. You will get the slides, so please read it after. And there are a couple of links, so please feel free to click that. I will now do this one quick. So in 3 steps, Madaster will create sustainable value for you. Environmental, the climate crisis, you will gain insight within CO2 emissions, circularity data, and I think that's also important within your business. Compliancy, like for example the ESG, the EU taxonomy, we need to have such a certification, and if we don't have the data, that will become a problem in the future. So if you are going to early register every material and your buildings within, for example, Madaster, the compliance is also getting a lot easier. And as third, financial, like I think a good example is stranded assets. If an asset is becoming older and older, it's becoming maybe too expensive to renovate it. So it's good to know what you have in order to see what you need to do with that. So also in Madaster, because we can use IFC models, we can guide performance within 3D. So for example, here you see the colors green and red. So in green, you can generate information on like circularity, and see which components within your BIM model are more circular and which are less circular. So red is more circular. And this can be done for KPIs such as embodied carbon, circularity, and also the building mass. Madaster can report and certify, so we can generate a material passport. For example, in the Netherlands, when you have a material passport, you can gain 1 BREEAM credit. And I can imagine this will also be in other countries. And also, like, it's possible to get a passport that's like more a general summary. So just a quick like circularity insights and all that kind of stuff. But you can also like generate a whole technical report which contains every, like, if you want, every screw that comes with it. So the platform does have that capability. It's also possible to within Madaster benchmark. So if you have like a building A and you are now doing building B, you can compare them with each other and see which building will score better. Some use cases, please also click on it. We're also busy now with the Dutch Expo Pavilion in Osaka called New Dawn, and that will also be fully registered in Madaster, and it will be designed by the Dutch architects, Rauw Architects. So please, if you have the slides, click on it, and these are some user cases of Madaster. So we use a partner network within Madaster, and we will use that like within whole Europe, and we hope within the whole world. So with the partners, we will accelerate our knowledge, and we'll gain more and more data in order to better the platform and make the usability more friendly for everyone. So what we think is what next, as we would say as Madaster, take full material responsibility. I would like to thank you for your attention. Feel free to contact us anytime, and if there are any questions, I'm happy to answer them.
Does anyone have any questions? Thank you.
Thank you.
I would like now to invite Julian, that will be presenting a AMPB energy solution, which develops battery energy storage systems in construction sites in order to facilitate the electrification of work sites.
Thank you. Can you hear me?
Yes.
Perfect. Thank you very much. Thank you very much for having us today. Super exciting. It's always nice to be involved with Impulse, so thank you very much. So to introduce myself, I'm Julian de Jonquière. I've been with AMPT for about 4 years, and then I've recently moved to Europe to open up our Europe and Middle East business here, but we have teams all over the world. So a little bit of history. We were founded in 2015 in Hong Kong. We were founded as a company focused on lithium-ion battery technology, but really our company only kind of got properly started in about 2017 when we were approached by a construction company. And that construction company said to us, can you do anything, can you remove any of the diesel generators that we tend to use on our construction sites? And so we worked very, very closely with them to work out that you could. So number one, it was technically possible. It would solve a lot of the issues around diesel generators, and you could do it at a price which was economically attractive to the construction company. So from that point on, we refocused ourselves and developed a lithium-ion battery which could be used in construction, and focused on creating an emission-free future for construction. And that was really since 2019. But what we've realized since is that you can actually use these mobile batteries, which are incredibly easy to deploy, move around and so on, for many other things. And so we have expanded our vision into looking at clean energy delivered. So really our focus is on removing or reducing the amount of diesel that's used in kind of mobile applications. So that might be construction is a very big case, but it might also be events. It could also be film and TV situations and so on. So now, having had this technology and having it being very effective and reliable and user friendly, we are now expanding our vision beyond that. So, but let me take it back a little bit to construction, because I think that's the area that obviously I think this audience is particularly interested in. So when we started working with this construction company, we went and visited a lot of sites, and what we realized is that diesel generators are being used to power a lot of the equipment. Now, that could be because there was no power connection available at all at the site, but it was also in many cases because the site could not get enough power. And so they had they could find a very small connection somewhere nearby the site. But to get a very large connection on some of these construction sites where you needed thousands of amps to operate, it took a long time, was too expensive, and they basically had to supplement it by using diesel generators to power a lot of the large equipment. And there are many issues with diesel generators. Construction sites don't like using them on the whole, because I mean it's been a de facto power creation method for a lot of these construction sites, but they cause a lot of noise, which is obviously bad for the local community, but also bad for the people working on those sites. They tend to be pretty unreliable, so they break fairly regularly. And funnily enough, the cleaner versions of the generators the cleaner the version of the generator seems to break more frequently. But you also have to refuel them. You have to bring trucks of diesel inside. It takes up space because you need diesel tanks next to the diesel generators. And so sites really don't like having to operate these. The diesel itself is actually a fire hazard, so you have to be extra careful with those hazardous materials and store them properly. Most diesel generators are old technology, so they don't have any connection. They don't have much data that you get back from them, so you can't really see how they're operating or how the equipment to them is operating. But most importantly, of course, they have a very high carbon footprint, and they emit a lot of air quality pollutants too. These generators are running all day during the construction process, and they are very big engines. So compared to cars, they emit a lot of pollutants. So what we did is develop together with this company the Amped Entertainer, energy container, which is a cloud-connected energy storage system, which has been designed specifically for construction sites. There are things that we've done to make this as simple to use. So it's a very, very easy to deploy system, very similar to a generator. There's a lot of extra safety aspects in there for the construction site. It's mobile, so you can move it around. You can see that it's got the rigging points around the top. So it's easy to move around when you need to, and it has a digital platform which is focused specifically on the construction industry, which has been very well received, because we can often do preventative maintenance and see if some issues are happening, and you get a lot of operational data back from it. And so how this works is essentially a lot of construction equipment needs quite high power, but not very frequently. So a crane, for example, when it's lifting a weight, it tends to have a very high power spike. But then most of the day it actually doesn't do very much. So say 95% of the day, it's not doing very much. So, but what you need to do is you need to power it with a very big diesel generator, which just sits there idling, burning fuel a lot of the time because it's not doing anything. What you can do with a battery is take a much, much smaller power feed and have the battery manage those very high peak loads. So just to give an example, on some large cranes, you might need 400 or 500 amps of power, which would usually require a 400 kVA or 500 kVA generator. We can power that on 20 amps or 30 amps. So you can either use a very small grid connection to this, or you can use a very small generator run very efficiently, which vastly reduces the amount of diesel and emissions. And if it's a grid connection, you can sometimes have no emissions at all. And what this means is you can reduce your carbon footprint by 85%, up to 85 to 90%. Actually, in the UK, it's more like 90%. You can completely eliminate the air quality pollutants, which affect the workers and people around the site. It's much safer because you don't have to handle the diesel. It's 32 times quieter than a diesel generator, which not only is better for the workers and their ears and the local community, but actually allows sites to work longer hours sometimes, because a lot of sites have limitations on noise up past certain hours. And also what we found out is it's more cost effective. So you actually can save money by using a battery on these sites, which is actually why most of our customers do it. We give a lot of data back. So we have remote operations and maintenance, and it gives the site, sustainability people in the construction companies, the operational people with the unit, the project directors who want to understand how busy a crane is, a lot of data back that they can understand how their construction site is going. And it also increases productivity. So, some of our customers tell us, they lose 300 hours of productivity per year due to refueling and servicing of the diesel generators. Our product is incredibly reliable, which brings back a whole lot of, which means that people can just leave it there. It does its job. You don't have to touch it or anything like that. So because of all these factors, we have been relatively successful. We delivered our first product at the end of 2019. And since that point, we've had 200 units delivered. Those 200 units have now clocked up over 2.2 million hours of operational time across 170 projects. We have over 60 customers in Australia, UK, Hong Kong, and Singapore. And we're operating in those regions. We're having units now being sent out to the UAE and the Middle East. So that's coming soon. Most importantly, we've mitigated over 29,000 tons of carbon dioxide, which otherwise would have been emitted. And we have removed the equivalent of 60,000 cars from the road in terms of air pollution. This is our platform that we have developed. So we are a product company. We design and engineer the hardware, and we build the software ourselves. So our platform is a very easy, simple to use platform. We've designed it together with a lot of the construction users. So it's designed to be easily understandable. And the great thing is it continually updates over time. So the product gets better and better. And we give real-time operational data. There's remote maintenance functionality where we can understand what's going on with the unit and prevent something before it happens. Carbon reduction information in there and energy reduction information. And then we also provide things like monthly reporting for people to go back and see how the unit's been operating over the previous months, which is great for sustainability people, energy people, even the people who look after the product. So what we have now done, as I mentioned, is expand our initial product line. So the Entertainer was really our first product. The Entertainer M and the Entertainer L were our initial product. But what we've done is taken our expertise and expanded it into a higher energy product. So if you look at this graph, the graph essentially shows with a battery, like the power level on the y-axis and the energy level on the x-axis. So the Entertainer L Plus is a much higher energy, so there's more capacity in there. And same high power, which allows us to do a lot more different use cases. And we're also next year bringing out the Silo. The Silo is a smaller energy storage system, which will be usable and more economic in certain smaller power use cases. And so we have a different range there. And these are just some of the things that we have either had customers come and ask us about, or we've actually implemented, which are different types of use cases. So we'll be, with the smaller unit, we can look at smaller site office setups, smaller cranes, concrete plants. So the operation of concrete plants, which is often driven by diesel generators, welders, maintenance, so roadside maintenance, even railway maintenance as well. concrete pumps, which require very high power when they first start, and then EV charging. So we see that specifically in the construction sector, where more and more equipment is being electrified and needs powering. And so that is it's my presentation. Please be in touch with any questions.
Thank you, Julian. Does anyone have any questions? Feel free to just unmute your microphone and ask your question. Oh, we do have a question here in the chat. So Julian, have you introduced your project to other areas? What is the difficulty of using your product in foreign countries?
We have now our products operational in Hong Kong, Singapore, Australia, and the UK. We are now sending units out to the UAE in the Middle East, and we're actually opening up a US business this year. So we absolutely are operating in different markets. The difficulties of different markets. So in many ways, the operations are the same, the way a battery works, but the difficulties really come in the localized implementation, whether that's compliance related, things like in the Middle East would be temperature related as well. So the different operational, the way it has to operate. Obviously, making sure we have strong partners in each market that we enter is very important for us, because we want to, number one, we want to have a really good customer and partner to start our business, but also we need people who kind of really believe in what we're doing, and people to partner with us on the operation and maintenance, the logistics, all those kind of things. So yeah, that I can. If the questioner wants to get in touch, I can talk more about that. But depending on each region, there's different challenges that we face.
Thank you. Any other question? Made me think, actually, when you said about the heat waves, do you have any safety technology, including, I don't know, flooding, the heat? How does it work?
Yeah, so I mean, we were, I guess, in some ways lucky to start our business in Hong Kong, because Hong Kong is quite a hot country, which does have typhoons and high humidity, and so we had to design the product to be able to cater for all of those use cases. But as we left Hong Kong, of course, Europe, we have very cold temperatures, and so that's something that you need to, especially with batteries, you need to make sure the temperature is managed effectively for the life, not for safety, actually, more for the lifetime of the battery. So we've had to adapt the product for that. As we go into the Middle East, that's like another level, because that gets up to 55-degree heat in the desert. So these are definitely adaptations we have to make, but everything's done with safety in mind. Like batteries can operate at like 200 degrees if they need to, and so that's not necessarily a safety related thing. It's actually more of a lifetime, but other aspects of the unit there's a lot of safety systems built in.
We have one last question for you. How long does it usually take for contractors to reach the payback period if they are about to buy the unit?
Very good question. It depends a little bit on the market, because the cost of diesel is obviously something that affects the pricing. In the UK, it's 2 to 3 years. Hong Kong can be 2 to 4 years, something like that, and the unit lasts 10 years. So if purchased, it's actually, if you look over the life, reductions from the product. It's more expensive than the diesel generator, but because you get the diesel reduction over time, you equate quite quickly.
Perfect. Thank you. Thank you so much for your presentation.
No problem. Thanks very much.
Dror will now present Thermoterra, which commercialize low-cost intelligent walls that control temperature and humidity variations in buildings.
Yes, hi. I present my screen.
Yes. Okay.
Great. So my name is Dror. I'm Thermoterra CEO, and I'm thankful for the opportunity to present to you and seeing all the amazing things that you are doing. In the same way we have learned how to harvest wind energy or solar energy, Thermoterra have learned how to harvest the energy that lays in humidity fluctuations and use it for cooling and heating of buildings. We are not only addressing the negative impact of energy on our cost or the CO2 responsibility of buildings, but we are also addressing the health issue of air conditionings. On the cost issue, we can save 50 to 80% of the energy needed for heating and up to 100% of the energy needed for cooling. Thereby, we reduce the carbon footprint of buildings, and we can make our system also with carbon capture materials. On the health issue, we are addressing 5 different aspects of our well-being, including radiative temperature, humidity level, and fresh air. So how we are doing that? We are taking the absorption capability of off-the-shelf construction material, such as bricks or insulation, and making those material into a humidity reservoir. Once we evaporate humidity from that reservoir, we get evaporative cooling. And when we harvest humidity back, we get absorption heating. We are using air canals, such as holes in the blocks or air gaps in the walls, and use our IoT ventilation unit to blow air through it, ambient air through it, and then controlling whether we are going to do cooling, heating, or absorbing humidity for next cooling. On the right, we can see a tiny construction we made in one of the universities in Israel, where we made it in the same side of a reference building that is used there for different researches. And we are going to see in the next slide the results. So on the yellow line, we see the ambient temperature reaching almost 36 degrees. On the orange, we see the reference building getting to 32 degrees. And on the blue line, we can see Thermoterra technology walls cooling the buildings by more than 10 degrees, making the building comfortable all day long. On the left side, we can see how this happened. So during the night, relative humidity was higher. Actually, this is what usually happens during night. So our reservoir could harvest humidity from the ambient air. In the first hours, it was stored. And then when cooling was needed, the wall started evaporating the humidity and thereby getting this amazing result of cooling. On this slide, we see a few days of these results, starting in the same temperature. Both buildings were starting in the same temperature, but our construction, using its ability to cool, was just keeping 24 degrees all of those days almost without any energy needed, just by the energy that was harvested from humidity fluctuation. And although our construction was thinner compared to the reference construction, it's having amazing cooling results. So there are many companies that are trying to solve the negative effect of air conditioning. Some are using smart thermostat as next. Others are using evaporative cooling or even photovoltaics. Some are using heat recovery ventilation. But there is no company that is doing all in a cost-effective manner and a low carbon footprint. In our business model, we are using our construction partners' capabilities, so they will make our adjustment, the wall adjustment, so there will be Thermoterra-ready walls on the market. Then we will directly sell our services and IoT ventilation unit to the customers. Our partners will not only gain easier complying with regulation and providing premium building for the customers, but they will they will also save directly on their costs. In this example, we can see that our construction partner can save 10 to 20 euro per meter just by making the walls thinner. And the building owner, the end customer, will return in investment in only 26 months. The global green building market is huge, more than 700 billion. Still, we are addressing a very small market. For our entry market is the natural fiber insulation that is best suited for our OLI adapter, since it's both conscious for carbon footprint and health issues. We already got engaged with some construction partners and manufacturer partners. One of them is Stako, a German insulation company that sells for more than 60,000 houses a year. And the construction that you saw before was with their materials. Our next market are the building retrofit, which is a huge market that is going to be like in Europe. They're planning to build more than 35 to renovate more than 35 million building by 2030. We will address also the photovoltaics, the building integrated photovoltaic market, where we can, on top of cooling the building, we can give a value of reducing the photovoltaics temperature, thereby increasing their manufacturing, the capabilities. We will address the double skin facade market and the acoustic tile markets. We already have our first customer, Elot municipality, which we are finalizing our agreements. We are going to industrial our technology in 2025, scale up in 2026, and hopefully get to break even in 2027. We funded our company after winning a grant from the Israeli Ministry for Energy. We have 3 patents. The first one was already granted. We won different competitions and grants and validate our technology with TransSolar, a thermal simulation company. We managed to raise more than €500,000 from private and public funds. In our company, we have 2 PhD in physics, Jonathan and Jeremy. We have Noah Milan, a business developer that was leading some successful Israeli startups as Electrian. We have Yael, which is an energy expert, in policy expert, and more on the team. Thank you for that, for hearing. And if there are any questions, I will be happy to hear.
Thank you, Dror. Feel free to write it down or just turn your microphone on. Oh, we have 2 questions. The first one is, what kind of wall structure should be applicable for your solution? For example, load-bearing precast walls, masonry walls, and so on.
Actually, we did experience with the 2 examples you mentioned. We were working with bricks, we were working with light construction, we were working with molding. So what we need is just the material that we actually using the construction material, and we need air path. So in molding, it's very easy to put pipes, net of pipes. In bricks, we just use the holes in the bricks. And in light construction, we use air gaps that sometimes are already done. So we can adjust ourselves to different construction methods. Even in a double skin facade, we were using the air gap between the glasses.
And can your solution be integrated with existing buildings? If yes, how?
Well, we do have, we are a great desire to answer retrofit market. So we have few good solutions. For example, if there is a building that already exists, and usually and you want to make a deep retrofit, so sometimes you're making an extra insulation layer. So instead of making something like 10 centimeters, we can do it with only 3 or 4 centimeters. we can do also something very interesting in historical buildings that you don't want to put extra insulation at the exterior. So you need to put it inside, but then you make the house thinner. So on that place, we can just make it 2 centimeters and have our material outside. So we have very good solution for the retrofit market as well.
Perfect. Our last question is, how does your technology work with very high humidity environments?
Well, this is a very nice question because I was all the time talking about humidity, but actually I was meaning relative humidity. Now, relative humidity is a function of temperature. And once you have temperature differences between night and day, then you are having relative humidity differences. And we just need the relative humidity differences. So we are harvesting when it's high, and then during the day when it's hot, we can release it back.
What would be a relative humidity when you say what would be the numbers?
Well, we were working, most of our experiment was in Israel. So we were working in Tel Aviv, which is very, very high humidity. So it's reaching between 90 to 60, and we have a good result there. And the last experiment was in the desert, and there it's more to 60 to 20. And then we also have good result there. So we just need a fluctuation.
Perfect. Thank you so much. Thank you for your presentation. It's very interesting.
Thank you.
I'm now very happy to welcome Christian, who will present CraftBlock and their energy storage system that enables the transition from fossil fuels to renewable energy in industrial processes and recycle waste heat.
Okay, thank you very much. I'm sharing my presentation. So hope everybody can see it right now.
Yep.
Okay, so first of all, let me introduce myself. My name is Christian Kissling. I'm heading sales and business development of CraftBlock company. CraftBlock is a company, a German company located in the very western part of Germany. We are established in 2014 as a startup. Meanwhile, we have built our first reference plant in 2019 in the ceramic industry for waste heat recovery, and we have signed commercial contracts last year with famous companies like PepsiCo or Tata Steel, which I also will introduce you during my presentation. So overview of application, you see our storage is a very multifunctional application. You see the storage located in the middle, either as a stationary one or a mobile one. The energy, it is a heat storage system, and the energy can be tapped either from waste heat coming from industrial high temperature application, or also it is possible to take the heat via so-called power to heat application, which I will explain later on a little bit more in detail. And after having it stored in our storage system, we can use the heat when we are now focusing on construction technology, district heating or quarter heating applications. But of course, it also can be applied in integrated into power generation, as well as, and this is from our point of view, also the key issue to make use of the heat in the downstream heating process, either as hot air, either as process steam, or as thermal oil. So the speciality, what is it? Unique selling point of our application is that we can tap energies up to 1,300 degrees Celsius. We start about 350 degrees upwards. We have a very modular setup. As you can see, the containers, these are 20-foot containers. It's either one container or several of them. And the storage duration is from several hours up to 2 weeks. We have our material, it's a granulat. I will show you a little bit later on. It has a very high heat capacity. We tested our material in life cycles up to 15,000 life cycles, heating it up from ambient temperature up to 1,200 degrees and back. and we figured out there was no degradation. And what is very much of interest is that the material of our pellets is containing up to 85% of recycled material, which is, for example, the slag from the steel or from the glass industry. How does this storage work? You see in the storage container, it is like these pellets. So our storage material are pellets which are 2 to 4 centimeters in diameter. And this is actually just a container with an insulation system and filled with the pellets. And the charging is just done by hot air, which is blown through the material and is heating up the pellet material to the related temperature. Then during storage, the temperature is kept within the material at the temperature level up to about 2 weeks. This is depending also from our insulation system. And when the discharging, that means when you make use out of the energy, again, we are blowing ambient air through the container. The air is heated up from the material and it serves with the temperature whatever you have stored for the downstream processes. So, and for the downstream processes, even we come out here, for example, with 800 degrees. If you only need hot air, for example, of 200 degrees, it is just a simple apparatus to be adapted like a mixing chamber where you use ambient air, 25 degrees with 800 degrees air and mixing it down to the required temperature level. Similar for steam production or similar for thermal oil heating. That means the storage is made very simple and all the apparatus, what you need for charging and discharging, are outside of our storage system. So I now come to the way how to charge it via the electricity side. It is via green power. That means we are using either solar power or wind power and are using so-called power to heat systems, which are like industrial hair dryer, if I may call it like that. They are available in megawatt class and serving temperatures up to 800 up to 1000 degree. We could store the energy here and then serve it for the downstream process. So the advantage is renewable energy mostly is a cheap power which can be used in the European market. We have fluctuating power prices on the stock market, and you also could make benefit of the volatility of the power prices. Curtailment of especially wind power in Germany can be prevented. It serves supporting the grid relief, and we can decarbonize downstream processes up to 1000 degree and by this replace fossil fuels. The industries, it's the food industry, chemical industry, and steel industry, and all industries needing process heat, which goes up to 1000 degree, or of course to a lower level, and of course also down to district heating of 80, 120 degrees. This all can be done by related apparatus downstream. We have this PepsiCo project I just mentioned about, where Eneco is a utility, and we take the power to heat up our storage system up to 800 degrees. We are presently building the largest worldwide commercial high temperature heat storage of in total 150 megawatt hour useful capacity, built in 5 new modules. And the 2 of those 5 modules, what you can see here, we are realizing by end of this year. And we are using the existing infrastructure, and just the gas-fired boiler, which is required in the potato chip producing for heating up thermal oil, is replaced with our storage system. That means the thermal oil, which is needed to heat up frying oil to fry the potato chips, will not be heated by gas-fired application, but will be heated by hot air of 800 degrees coming out of our storage system and coming out of our storage system and heating up the thermal oil from 250 to 300 degrees in order to do this process. So at the end of the day, when all 5 modules will be installed, 98% of the emissions will be avoided, and PepsiCo is offering green potato chips. Next application is the waste heat application. Here in this case, we take the waste heat from industries, which again will be stored in our storage system and can be applied downstream. So whatever is used on process heat Using waste heat, we have a reduction of primary energy. We are reducing emissions. We have a cost saving, no new energy needed to be tapped. And we even can take the high temperature from the glass industry or steel industry before the cleaning process. Correct. The waste heat projects we have, 3 of them, I go through them quite quickly. This is our reference plant where we take from a batch oven in the ceramic industry. We are collecting the heat for using it for the next heating up of a batch process. This project here is in the steel industry with Tata Steel. And the last one, which we are also just realizing, is taking a flare gas from the steel mill, combusting it in an adiabatic combustion chamber and serving with temperature of 1200 degree, put it into a storage, and in this case also have it as an application of mobile heat. That means this heat will be transported from A to B, what you can see in this devices. So this in this scheme. So this is opening new business models with waste heat. That means heat of up to 1200 degrees can be transported by truck and can be coupled to downstream application. Up to about 3.5 to 4 megawatt hour useful can be transported. The problem is the street has a maximum transportation weight, but it also can be scaled up by a fleet or even a train application. And we have already a first mobile heat application up and running. In the city of Hamburg in Germany. We take the waste heat from a biogas combustion engine. We take the exhaust heat, about 430 degree, put it into our storage, truck it from A to B, and connect it on a docking station to heat up office building. So and this is a kind of decoupling, not only time-wise, but also location-wise of energy, bringing it from A to B and make best benefit for decarbonization. And it's the last slide. It's about district heating solution, which can be applied via our system. So we can take different sources, but they can all be handled within our system. With this, we are increasing the flexibility of a district heating system or of a quarter heating system. It's a cost saving of available cheap energy. We are decarbonizing all this district heating. And what is also maybe of interest in case of integration of new district heating system, in the beginning, we can start with a so-called 2-point grid when we are using this mobile application. So the acquisition of new clients can be supported because it takes a certain while until all this approval will be given for related connection and later on the realization itself. But using the heat transported by truck can overcome this at a very early stage in order to serve new clients with district heat. And yes, this is it. Thank you very much for your attention. And if you have any questions, please let me know.
Thank you, Christian.
Mhm.
Let me check the chat if we have any questions.
We'll have an open Q&A session at the end of
Okay.
the session in case people have questions. Then.
Thank you.
Okay, thank you.
So for our last presentation, I will invite Danny. We'll present Electric, which develops a system that turns hydrogen into a powder for easy bag storage and transportation for use in off-grid applications and long-term storage.
Thank you. And yeah, I trust you can see my screen. Hello, everybody. My name is Danny Weber. I'm VP Business Development for Electric, and I am very happy to be here. And thank you, Impulse Partner, for arranging this fine event, which I'm happy to close. So without further ado, here in Electric, we're defining the last mile hydrogen delivery. And before I start my presentation, I would like to show you a magic. In my hand now, I'm holding solid hydrogen. Let's investigate what does it mean. So hydrogen is key to reduce carbon emissions globally, as we all know. The good side of hydrogen is that it's the most abundant element in the universe. It's lightweight and eco-friendly energy source. However, it has some downsides as well. It's hard to transport and store it in a compressed and liquid state. It has a low energy density in gases and liquid form. And when stored as liquefied or compressed hydrogen, it is flammable and explosive, which obviously is bad, especially in construction sites. So, Electric pioneered a breakthrough technology that will transform the way hydrogen is stored, transported, and used. We have developed a novel type of hydrogen ecosystem based on the energy-rich proprietary powdered hydrogen, which I just showed you, and the release system that you can see on the screen now. This, you cannot see it, but this release system is actually mounted on a crane. It was demonstrated in the Netherlands last year, powering the crane's operation. So our solution is based on two legs. The first one is the powder. The electric powder is safe for transportation and storage. It is inert and non-flammable. And we produce it in a production and recycling plant. After the production, the powder is sent to the customer location to be used as a fuel for the hydrogen release system. The release system is working in low temperature and low pressure, and it is optimal for off-grid applications. Construction sites is such a key application. After the system completed the extraction of hydrogen from the powder, a process that includes mixing the powder with water in a catalytic process. All the powder, all the hydrogen is extracted from the fuel, and the remaining byproduct is a liquid that is sent to the plant back for recycling. This means that our solution is circular, and the powder is functioning as a hydrogen carrier, carrying hydrogen from the plant to the side of the customer, and then being shipped back to the plant for recycling and reshaping it back into hydrogen powder. So the core of our value proposition, first and foremost, is that the powder is distributed like everyday products as long as it is kept dry. Think of it as coffee or washing detergent. We do not need any special infrastructure or logistics to transport or store the powder. It has superior energy density than compressed or liquefied hydrogen. I will elaborate in my next slide. The hydrogen can be stored for years within the powder. The chemical binding is very strong, and we don't have any loss of hydrogen from it. And the power is generated with zero emissions and on demand. We release the hydrogen based on the electricity demand of the operating devices that are connected to the system. And the hydrogen is released 5 nines pure, which means that it is fuel cell compatible. To touch on the energy density, if we compare the energy density of our powder to other last mile power and energy carriers, we illustrate it by the amount of energy that you can store in a 20-feet container. If you look at my slide, you can see that our solution is 2.5 times better than compressed hydrogen, 700 bars, 50% better than liquefied hydrogen, and about 4 times better than lithium-ion batteries. So, how does it work? The process is based on mixing water and the powder in the reaction chamber using a catalytic valve. And I think it's best that we just see a short video. So this is our genset. for illustration purposes, we have also a fuel cell in this device. We put the powder, in this case, in a capsule form, into the system. Then we mix the powder with the water in the blender, and we heat it to 50 Celsius degrees. And then we move the fuel to the reaction chamber, where the catalyst here in the top side is controlling the amount of hydrogen that is released from the fuel. When the catalyst is put fully and is fully covered in the fuel, you can see all these bubbles. This is hydrogen that is being depleted from the fuel. Once released, the hydrogen is moved to the connected power device. It can be a fuel cell or an internal combustion engine that can be used for various applications. So, our target markets, starting with construction sites, but actually any off-grid, off-road machinery, defense applications. You can imagine the benefits you can get with a fuel that is not explosive nor flammable, with a higher energy density. And also critical infrastructure, mostly for backup applications. It can be communication towers, but if you're talking about the construction industry, also we have currently discussions with customers who are looking for backup applications for elevators in high residential buildings. If we're looking at the construction site use case, we need the off-grid power source to on-site mechanical equipment such as crane, the local office or shed. And there we are going to bring to the market a 25 kilowatt hydrogen release system with a fuel cell that will actually displace the diesel genset on site. The alternative solutions that we see in the market today are compressed hydrogen and batteries. However, compressed hydrogen cannot be used everywhere. The permits take time, and of course, we have safety concerns to address. And batteries, by and large, they are expensive. Today, there are limitations in supply and capacity. And we need to also take into consideration that they are not 100% green, taking into account the production and recycling CO2 emissions. So electric is ready for commercial rollout. We are building now the first powder production and recycling plant in the port of Amsterdam, together with Zenith Energy Terminals. We have already developed two proof of concept gensets of 3 kilowatt and 8 kilowatt. And we are going to launch our 25 kilowatt hydrogen release system next year. And we'll be more than happy to discuss partnership on evaluation of our technology.
Thank you, Danny. We already have a couple of questions for you from the participants. The first one is, how much does it cost compared to a normal hydrogen operation?
So I would say that by definition, we are taking green hydrogen and we are binding it to a powder, and this process by definition costs money. However, our target price will be under €1 per 1 kilowatt released from the hydrogen.
The second question is, how about efficiency of your product? Do you have an example of levelized cost of storage?
So in terms of the efficiency of the solution, we don't require any energy to release the hydrogen from the powder. The hydrogen release system can release, I would say, near to 100%. We're talking about 98, 99% of the hydrogen that is released in the powder. I didn't mention that half of the hydrogen is contributed by the water in the spontaneous exothermic reaction that happens when you mix the powder with the water. So in terms of the energy efficiency of the solution, it is very high. You invest energy in the production of the powder. This is done offsite in a chemical plant that we are operating, and this is the only place where you need to invest energy. However, we are working with green power and green hydrogen, and our carbon footprint is much lower than diesel. Since we are not only decreasing the cost of the production of our powder, but we are also recycling the powder, and therefore the only carbon footprint is based on makeups of materials that are done in the production of the powder.
Perfect. The last question that we have for you is, you stated that the powder product could not get wet. Does this include high humidity environments? What are the storage requirements?
So the powder is a known material. It's called potassium borohydride, KBH4, that is used today for other applications. It's a specialty chemical used for pharma, food, pulp, water treatment industries, etc. And there are very clear instructions regarding the storage of the product, and all you need is to store it in a barrel. Sometimes it will be in a plastic bag. I can show you that. I have it here wrapped in clear plastic on my desk, and it's here for quite some time. So there are very standard and simple procedures to maintain the safety of the powder.
Thank you, Danny.
Thank you.
Well, if you have any further questions about the presentations, about the program, do not hesitate. This is the time for an open discussion as well. If you have any thoughts related to this topic of energy and clean tech. As far as I remember, there was someone that raised their hand in the beginning of the presentation from Shimizu about the accelerator. So if you still have a question about this, I don't remember who it was.
I think it was my boss, Daisuke, just to say well done. Yes.
Yeah, it's my mistake. Sorry.
Yeah.
Well, if anyone has a question about the Shimizu accelerator, you can always contact them after as well, or us even. We'll be more than happy to answer to any questions. Well, thank you. Thanks a lot, Yuri, for your presentation. Thanks to all the startups that took the time to showcase their solutions today, and to all the participants that have joined the session. We'll be sharing the pitch decks presentations to all the participants, so don't hesitate to take this discussion to the next step. We also have more events like this one coming soon. Our next online innovation session will take place in September and will be focused on digital construction. So if you're ever interested in taking part of this session, contact us and we'll make sure that we'll invite you. And overall, thank you for being here today, and we hope to hear from you soon and to see you all in September. Have a nice day.
Thank you.
Thank you.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye.